Hi, I'm Jaehong from KAIST. In this video, I'm going to talk about neural-enhanced live streaming, improving live video ingest via online learning. This is a short 10-minute video, and if you want to know the details, please watch the 20-minute video. Live video traffic has experienced a rapid growth with the rise of live streaming services such as YouTube and Twitch. With the number of streamers and viewers on the fast rise, supporting high-quality live streaming has become ever more critical. Live streaming systems consist of two main components. First, the ingest side concerns the delivery of live video from original streamer to a media server. When the streamer uploads a high-quality live video to the media server transcodes the ingest stream into video chunks with multiple different low qualities. Second, at the distribution side, content distribution servers use adaptive bitrate streaming to optimize the quality of experience and scale across thousands of concurrent viewers. However, there still exist key limitations in an end-to-end live video delivery. The stream quality is fundamentally constrained by the streamer's uplink bandwidth and its computational capacity. For example, if the network bandwidth between the streamer and the media server is scarce, or if the streamer lacks computing power on their devices to encode live stream in real time, the ingest stream quality suffers by limiting the transcoded options and restricts the quality of the entire delivery downstream. This potentially deprives thousands of viewers of their opportunity to enjoy high-quality live stream. Therefore, in this work, we focus on the first hop delivery between the streamer and the media server, namely the ingest, and we propose a new live ingest framework called LiveNAS that aims to enhance the video quality of origin stream at ingest. By leveraging the computing power at the ingest server, LiveNAS applies super resolution on the original stream at the ingest side before its distribution to the end viewers. Since the high-quality video is now available at the media server, this enables thousands of viewers to download high-quality live stream if they have enough bandwidth. However, there are two primary challenges of applying super resolution in live streaming. First, content-aware DNNs cannot be prepared on the fly for the new live content. It is known that super resolution DNNs provide great benefit when trained and used on the same content, namely the content-aware approach. In fact, to prepare the content-aware DNN for per video, it requires 10 minutes of training for a 1 minute of video. The approach cannot be easily adopted to the live video delivery considering its stringent delay requirement. In addition, pre-training a DNN to a video from past live sessions cannot deliver reliable quality gain compared to the content-aware DNNs. This is because the live content can be very new and different from history sessions. To address the challenge, our solution is to employ online training with fresh data while live streaming. Second, to train the DNN online, it requires powerful computing devices, but the computing power at the streamer side is heterogeneous. Instead, we can leverage the computing power at the ingest server, which is typically a cloud environment with ample computing resource. However, the challenge is that ground truth labels for online training are not available at the media server. To address the challenge, we rely on our key observation that even a fraction of ground truth labels are sufficient for online training. First, because video frames bear large redundancy, training with only a subset of frames still produces almost the same quality gain compared to having all frames. Second, in addition to sampling of frames, training with a fraction of ground truth labels, namely the patches, still provides a significant training gain. Combining these two factors, we can transmit ground truth labels to the media server using fairly small amount of bandwidth. For example, sending 5% of frame for every 2 seconds with JPEG compression requires only 124 kilobit per second. Leveraging this, our solution is that the streamer sends fractional training data to the ingest server. To explain in detail, LiveNAS operates both at the streamer and the server side. At the streamer side, the camera captures the high-quality stream before its compression, and LiveNAS samples partial high-resolution data, which is used for training. Then, the streamer sends the sampled training data patches along with the compressed live video frames. At the media server, the online training and super-resolution inference operate in parallel. The online training learns new features of a video stream online with received patches from the streamer and updates the freshly trained DNN to super-resolution processor. The online training approach, however, involves solving non-trivial challenges. First, the high-quality patches that a client transmits share the ingest side bandwidth with live video. Allocating large bandwidth for training patches can improve super-resolution. However, it leaves less bandwidth for live video, which can cause quality degradation. To address the challenge, we introduced the quality optimizing scheduler that effectively balances the allocation of umlink bandwidth between training patches and live video. Second, ingest server must support large number of streams. For example, there are average 90,000 concurrent streams on Twitch. If we naively dedicate one GPU for online training to each stream, LiveNAS can only provide benefit of online training to the limited number of concurrent streams. Therefore, efficient resource use for online training is required. To address the challenge, we introduced the Content Adapted Trainer. Now, I'll briefly explain the two design components. The goal of Quality Optimizing Scheduler is to allocate bandwidth use between the video and training patches that results in maximum video quality. Since we observed that the optimization goal is concave function, our Quality Optimizing Scheduler applies gradient ascent to find patch bitrate that leads to maximum video quality. Then the scheduler updates the target bitrate of patch and video respectively. The goal of Content Adapted Trainer is to improve the resource efficiency of the online training. Our Content Adapted Trainer suspends the training when it detects the saturation in the training gain and resumes training when it detects the scene or content change. In this way, LiveNAS is able to adapt the amount of training time to the real-time quality gain. Putting the design components all together, here is the overview of LiveNAS system. There are two additional design components that I have not talked about in this video, but they are explained in the 20-minute video. LiveNAS is implemented on top of the state-of-the-art open-source ingest framework WebRTC. Besides the WebRTC, LiveNAS design components can be implemented on top of any ingest framework since it is agnostic to video codec and transport layer. We evaluated LiveNAS by answering the following three questions. I will not go into the details since it is explained in the 20-minute video. To summarize the results, first, LiveNAS outperforms WebRTC by average 1.96 dB in PSNR under a constrained network environment. Second, LiveNAS delivers reliable quality gain with using only 25% of GPU resource compared to the continuous training. And finally, LiveNAS produces 12 to 69% QA improvement for live stream viewers. Before ending this talk, I would like to show you a demo. The left half is what WebRTC delivers under a network-constrained environment, and the right half is what LiveNAS delivers under the same environment. You can see that video is much clearer in LiveNAS. To sum up, I have briefly talked about three things in this talk. First, LiveNAS is a new live video ingest framework that enhances the original stream's quality via online learning. Second, LiveNAS introduces novel design components, including Quality Optimizing Scheduler and Content Adapted Trainer. And finally, LiveNAS produces significant QA improvement for live stream viewers. More information can be found in our website. Thank you for your attention, and if you have any questions, I'll be happy to take them during the live Q&A session.